Okay, in this video we're going to talk about evaluating more integrals, but this time involving a special technique that we use to solve integrals that are a little more have a little more to them. Okay, so this integral we have from 0 to 2 of x squared times the quantity 3x cubed plus 4 to the 7th power times dx. Okay, well, I could multiply that out, but I don't want to. Okay, trying to multiply anything out to more than maybe the 3rd power is crazy. Okay, it's a lot more. There's so much more than we need to do. It's so more than we want to do, and it has a lot of room for error when we actually go do the algebra part of it. It's a lot of room for error. We don't want to mess with it. So there's a technique that we use, okay, called substitution to make this a little nicer to work with. Substitution, to spell right, called the substitution. Okay, and what we do for substitution is, first of all, we establish a variable u, okay, and we say, what can we let u equal so that this integral is a little nicer to work with? Okay, so u equals 3x cubed plus 4. Why did I make it that? Well, it's considered a kind of a rule of thumb in calculus that we use whenever we do a substitution. We try to make u whatever is under the power. So in this case, we have 3x cubed plus 4 is under that power to the 7th power. So that's what we're going to make u. Okay, and then we're going to take the derivative of both sides of that. Okay, so we get 9x squared. And then 4 is derivative of 4. A constant would give us 0. So then we have that. Okay? So we take the derivative of this. We have du dx gives us 9x squared. But then if we solve for du, we get that it equals 9x squared times dx. So we have the dx there. Okay. So I want to somehow get this in the form of the integral from a to b of u du. Alright? So I've got my u part, the 3x cubed plus 4, and I know that I want to get it into, and I'm going to get the du part in there. So I know that du is 9x squared dx. Well, I've got the x squared and the dx, but I need to somehow get a 9 in there. Okay? Well, as with any good math problem, what we do to one part, we have to do to the other. Okay? So if I were to put an imaginary 9 in here, I put a 9 in there, I have to do something to balance it out on the outside of the integral. So on the outside of the integral, I'm going to multiply by 1/9 from 0 to 2, 9x squared times 3x cubed plus 4, all to the 7th power, and then the dx. Okay? So, I've got my 9x squared, my dx, okay? So if I were to kind of reorder my terms a little bit, then I have 3x cubed plus 4 to the 7th power times 9x squared dx. Okay? So I've got everything I need now. Alright? Except one thing I want to do is I want to take my limits now and I want to put them in terms of u. Okay? Because once we write this in terms of u, these limits don't go. The 0 and the 2, they don't work. Okay? Because when you get in terms of u, you're working with a different function entirely. Okay? So in order to get them in terms of u, I have to evaluate them in this function here. So u equals 3 times 2 cubed plus 4. I get 24 plus 4 is 28. That'll be interesting. And then I have to evaluate the 0 as well. So 3 times 0, well, that's going to be 0 plus 4 is 4. So now I have the integral from 1/9 times 0 to, or not 0, 4 to 28, okay, of u to the 7th times du. Okay, so 3x to the 4. Okay, that's my u. That became down there, and then the 9x squared dx is du, so that became that. Okay, so I did my substitution. Okay, so now I have u to the 7th. Okay, if I go back to my power rule, then I have 1/9 u to the 8th over 8 from 28 to 4. Okay, well, this is going to be a very big number. Okay, I will tell you that right now. This comes out to, if you simplify the integrand, that's what we call this part right here, the integrand, u to the 8 over 72 from 28 to 4. Okay, so how we would do this, we have to evaluate using that fundamental theorem of calculus. Okay, oops. Using the fundamental theorem of calculus. And so we have to do 28 to the 8th power over 72 minus 4 to the 8th power over 72, which is equal to a very big number. And that's all I'm going to say. A very big number. Okay? So, I think by the time students in calculus ought to be able to figure that one out for themselves. So, if we have, let's see, 28 to the 8th power is a number that involves scientific notation. So, it's a very big number, minus 4 to the 8th power. That's not much smaller. So about 3.778019 times 10 to the 11th all over 72. So it's approximately 5,247,248,156 is the value of that integral. So if we were to graph this function on the some kind of graphing program, then that would be the amount of area underneath the curve. Okay, so again, like we said earlier, that's what the value of an integral represents. So this would have a lot of area, so to say. All right, thank you.